Assalamualaikum and good afternoon. My name is Muhammad Rizal Bakar, and today I'm going to present my final year project, PSM2, which is titled of Image Processing Enhancements for Baggage Scanner Airport using Contour Stretching. And my supervisor is Prof. Muhammad Shanizal Bizunal. Introduction part. So this project is based on improvement based on from previous title, which is about the crowds detection. But this is already changed from the PSM1. Currently in PSM2, continue with the improvement part based on protected system that implement in the PSM1. But nevertheless, the introduction is about the introduction is about the how we perceive the image. So first, what is image? Image is represented by its dimension, height, and width, based on the numbers of the pixels. As for the what is the image processing? It is the process of transforming an image into a digital form and performing certain operations in order to get some useful information from it. Next, for the problem background. So there are three total of problem backgrounds identified throughout PSM1 and PSM2. First is about the X-ray image produced, not in very good quality in terms of grayscale and pseudo color. And for the second, the chosen techniques of image processing, which is suitable to solve the locality of X-ray image produced. And the next one is the requirement of image processing techniques that cannot be too complicated so the user can operate the system or apply the filter to the image easily. Next, for the project objectives. First is to design a system that can improve the quality overall image, which is display the output that can display the output of the inside of the baggage. Second is to develop and apply image processing on a simple image by using a few techniques of image enhancement. And next is to evaluate and analyze the performance of the image X-ray. Project scope is about the purpose of the image processing technology is to improve the quality of the image in airport security as a security precaution. For the second one is to apply the techniques in X-ray image should be able to show the better version quality of image compared to the original one. And the third one is about the enhanced image should be able to be saved in the database as a local disk of the user and can also be accessed by the user. For the summary of the literature review, in this project, there's a lot of improvement, especially in PSM2, since there are a few techniques are being changes and some techniques is removed and also some techniques also are being added since to gain the most optimized or to achieve the objective of this project is to able to process an image in a contrast stretching form. Hence, this project, this PSM2, uh, can be I mean, for this project for this PSM2, the techniques applied is definitely suitable and can be used as well in the current system, which is the Qt++. And for the summary research of the design, the same with from the previous PSM1. This chapter examines the this project using agile development process, which is really beneficial for PSM2, where there's going to be changes or implementation can be covered easily based on the prototype that already been done since PSM1. And since this is the major objective of the system is the same, technologies that used in this project also the same with by using the Python programming language Qt++ and Visual Studio Code. For Python and Visual Studio is already been done in PSM1 as a prototype. Currently, for the finalized PSM2 system, I'm using Qt++ as the main platform to achieve the main objective of this project. And this is the software and hardware that have been used. The next is project design. So there's there have been changes based on from previous PSM1, where in this PSM2 flowchart of using filter image in the system is different from before, where there's another additional techniques they may apply. For example, like Clahe, which is function as to denote the image. Piecewise linear is the main technique that used to contrast stretching on the image. And for the remain technique, which is on-shot masking in threshold, and also additional normalized filter that can be also applied to the image. In addition, the system PSM2 also, in this PSM2, the system also have an undo and reset button to optimize the user, to make the user able to optimize the image more efficient. And for the diagram architecture of the image filtering process, so you can see here the image acquisition is where the user load the image from their local disk. The process image is the normalization, and the noise apply here, contrast stretching, piecewise linear, edge enhancements, unshot masking, and lastly, threshold in apply threshold in order to gain the image binary. And throughout the system, the output will gain the user will gain the filter image with the histogram that can display the statistical data. This implementation, based on the image and histogram, the real-time preview also have been implemented in this part as well. Next is after that, in the user interface, the result will be displayed, and user can save the image in the database, which is from the local disk, and the user can also able to access back the image. This is interface design based on prototype, which is have been already done in the PSM1. As you can see here, this is the original image sample of the SRI image, and from here, there is not much difference on PSM2, where the original image is also in the color, also in the colorized, also in the color image SRI image, where the main purpose is to change the color image into the grayscale form. So next is the expected outcome based on the original image of prototype. So in the previous system, some technique that we implement into the system is process image. Some technique that implement into the PSMR is the kernel value and also alpha value, where the system is able to change the image in a threshold. Also able to filter the image with threshold techniques. And then next for the interface design of the finalized, which is the interface design that I'm using in the PSM2, based on the Qt framework. So as you can see here, this is the original image with the another samples. So as you can see here in this PSM2, I try to highlight the main objective, which is which the user able to filter the image in order to obtain the contrast stretching. In order to able the image, they already been applied with contrast stretching. So as you can see here, the target is the few items that with dark blue color spot that hidden or unclear inside the baggage. So in the system, the main task of the system is to able to clear the obstacle or any object they hide the hidden items, and able to show out the details of the hidden items in clarity, and the overall, and also improve the overall image quality. So here's the expected outcome based on the original image. So throughout this process, the system also be implemented with the filter pipeline, where all the techniques that apply on the system will be kept for the another filter to be applied on each other. So this is important to make sure the image can be obtained in more optimized and clear version. As you can see in this expected outcome, the hidden objects, which is in grayscale form, can be seen more clearly, where all the obstacles that hide the objects have been reduced and able to show the clarity of the hidden objects, which is based on the items that been highlighted with the blue color spot. This is the UI UX in the Qt C++ framework. So as you can see here, there's a load function, process function, undo and reset button. Also, this is a few there are checkbox and drop down for the filter to be applied on the image, and also uh the there are two histogram that can show the mean value, max value, mean, and also standard deviation based on original image and also filter image. Next is evaluation testing. So based on this pre-location diagram, there are total 4 users that have been using the system, and they're also able to provide each their own opinions based on the system performance. Overall, in this evaluation testing, most of the user experienced worker that already work in Lane Prima, with each of them uh have their own unique role occupation. For example, some of them are airport security personnel, medical imaging staff, and others have been clarified as a software engineer, while the other remaining is a student that from a BTM that can be useful, since we can see the difference opinions based on experienced user and first time user in using the image processing system. In this also, based on this diagram also, uh, fortunately, all of users have experience in using image processing software, with each of them have using different kind of software, and really each of software is unique to their own, since as you can see here, based on each different software that have been used, users can give their feedbacks based on their experience they using different software on the system that they are going to testing on. For this part is the post questionnaire, where as you can see here, these are the example of user evaluation based on scoring score form, which is one indicate as disagree, five disagree as one is strongly disagree, five is strongly agree, which is, as you can see here, most of the user uh, have have a most uh have a lot of good review on the system performance, and also some of the user compliment that the real-time preview that apply on the filter image histogram is really helpful for them to adjust and filter the image. Some also highlight that flaw of the system is the UI for them is a bit UI layout for the user is a bit confusing, and the unclear instruction and lag indicators can affect the user performance on the system. And this is overall feedbacks and suggestions from the user. Most of the user agree that the system able to achieve the main objective of this project, where the user managed to operate the system and able to produce a contrast stretching image, also with including other filters. Conclusion part is this project's overall accomplishment is really for this project's overall accomplishments are summed in this last chapter, and with also another shortcoming, and also able to offer possible feature in the works areas. For contrast stretching and other filtering techniques, the created systems effectively can be improved locally as a aggregate scanner's image. Systems Qt-based interface and model design enable real-time filter change with the consistent visual feedbacks. It's really helpful for the user, since this can help the user to able to optimize the image and the system can be performed more efficiently. Based on testing evaluation, tester also confirmed the effectiveness of the suggested methods through evidence of higher risk visibility. User satisfaction is is a mandatory as well. Nevertheless, the system had drawbacks with such a difficulty applying outside of the development environment, which is the system have an issue with running with standalone application, since the system also lacking in advanced features like region specific filtering or batch processing. Uh, in addition, by including the neural network models like adaptive filtering or enabling batch image processing in a one time, also can enhance the and also an ability to enhance the deployment fitting for the standalone. In this future development could feel a lot of the shortcomings for the system. Other functions that could improve the usability and practical applicability, including multilingual support, automatic announcement suggestion, and also comprehensive logs. This is the gunshot based on the PSM1, and then this is the gunshot based on the PSM2. And throughout the journeys, I really appreciate all the guidance and help from the one that support me, especially my supervisor. They give me a lot of guidance and highlight the details of the importance in developing this project. I also would like to thank you to the examiners and also my my friends and my families that helped me throughout this journey in making this final year project. And that's all from me. Thank you, Doctor.